15. Two parallel wires 2 meters long and separated by a distance of 1 meter are carrying equal currents. Each experiences a repulsive magnetic force due to the other of 1.6 times 10 to the negative 6 newtons. What is the magnitude of the current in each wire? Are the currents parallel or anti-parallel? So the first thing that I did was draw a diagram. We see here that each rod or wire is 2 meters and they're separated by 1 meter. And we know that the currents in each rod are the same. And then it's a repulsive magnetic force of 1.6 times 10 to the negative 6 newtons. So first we're going to look at this force. The force equation for wires and current running through wires is force equals the current times the length of the wire crossed by the magnetic field of that wire. So we know that the force given to us in the problem is 1.6 times 10 to the negative 6 newtons. And we're trying to solve for, and that equals the current. And this is just going to be any one of the wires. We can pick either one of them because the forces are the same and the currents are the same. Times the length, which both of them are 2 meters, times the magnetic field. And we know that a magnetic field experienced by any point because of a wire is, we have this constant times your current, the current that's running through it, over 2 pi d. And that d is the distance away from the wire in which the magnetic field is generating from. And so that's just going to be, let's just say we pick this one to be generating the field and this one to be receiving the field. That means that our d is going to be 1 meter. So if we plug all of this stuff in, it's 1.6 times 10 to the negative 6 newtons equals I times 2 meters times 4 pi times 10 to the negative 7th, which is this constant, times our current, over 2 pi times 1 meter. So then we're, all we do now is we're just isolating these i's. So we have I squared on one side of the equation. We're just moving this to the left and we're just dividing this. And so in the end, what you'll get is I squared equals 1.6 times 10 to the negative 6 newtons over 4 times 10 to the negative 7th. And if you plug that into your calculator, you get I squared equals 4. You just square root both sides. We find that the current in both of the wires, or in either wire, is 2 amps. And since the problem it's already given that it's a repulsive magnetic force, it must be anti-parallel, which just means that the current are running in opposite directions, because anti-parallel currents in 2 wires create a repulsive force. That's just definitional.